Hello everyone, welcome to my video today. Today I will sharing about the azimuth determination by a solar observation. I will include the field procedure and the calculation also. So I am CHUAN and I am now studying a Bachelor of Geometric Engineering in UTM. The purpose of I'm doing this video is to share about how to carry out the solar observation and how to do the calculation during the fieldwork. All my sharing is based on my understanding on the solar observation learned. So if that got any mistake, welcome to inform me and correct me. I will add my PowerPoint animation to bring you to experience the fieldwork and with some sample data of the solar observation. Let's go. First, we need to set up the instrument. So we need a total station, a prism we stand above our under our reference point, and we also need to have a sun so we can make our solar observation. Let's proceed to the observation for set 1. In solar observation, we need to do the observation with at least 2 sets of observation. Okay, first we proceed to the field observation. Okay, in the diagram, you can see that is a crosshead of the total station, which is target on the prism. So I will also make booking together with you guys and show you how to make a booking together. When we target to the back side of the prism over the reference point, we will get a reading of a horizontal angle 162.00. This is in the unit of degree, minute, and second. So in our booking form, we fill in this column the ufuk. This TR is for tanda dudukan, so we fill in is a degree, minute, second here. So we key in with 162.00.00 in this column. So for the time we not need to tag not because this is not a solar observation, we only tag the back side of our bearing. So next we will continue to make a solar observation. So this time is very important because we have to not the time when we are having a solar observation. So the time not of our observation is the local time. Next, we want to make a solar observation on the sun. So the time is very important for us to make the calculation later on. Next, we move the target to the sun at the edge right hand side. So we have to have a reading of this at the time at o'clock 28 minutes and 59 seconds. So we jot down the time here at 28:59, and the horizontal angle at the right hand side is here. We jot down at 96, 19, and 00. Okay, for the book is our vertical angle, so we jot down also for 74, 56, 20 in the column of buka. Next, we move the total station target on the left hand side of the sun. So we get a reading here. So we make a record on the booking at 2917. This is the time of the observation, and this is the horizontal angle, and the last one is the vertical angle. turn over our totalization into a circle right observation. We turn 180 degrees and make an observation on the left hand side of the sun. So we jot down the data also. Okay, last, we move our totalization target from the left hand side to the right hand side of the sun. We also make a record on our fieldbook. Okay. Lastly, we turn our totalization back to our bedside, which is thunder to CHUAN. So we have a reading of horizontal angle 342 degree. Okay. Next, we will continue and repeat the observation for set 2. The procedure is totally the same as a procedure for the step 1. So same as we read the observation on the bedside and jot down the reading and move the crosshair totalization to our right hand side of the sun. Next, move to the left hand side of the sun and we turn over our totalization for circle right observation. Then we read the observation at the left hand side and the right hand side of the sun. Then lastly, we target back to our bedside on the reference mark and jot down all the reading. So this is the overall fieldwork procedure for a solar observation. Okay, this is the data that I had discussed before from the stimulation of the presentation in the slide. So I have write down all the data in the booking form as shown in this booking form. So first we have to calculate the mean time of the observation by calculating this 1, 2, 3, 4 in order to get the mean. So we have to add all the time and divided by 4 in order to get the mean time. So the mean time is at 13. We round off. So in this we have to minus 8 because of we have to convert it to the universal time. So same with this, we will get a mean of 34. Minus 8, 0, 8, 34. Okay. For the Burrata Ketial is this and this. We have to get a mean 16200 plus this we have to minus 180 to get a mean, divided by 2 is 162. So same as this, Burrata is okay. So next we have to calculate the horizontal angle of the sun, which is this 1, 2, 3, 4. We have the 96, 95, 275, 276. We have to add it together and get a mean value so that we have the bearing horizontal angle Burrata ke Matahari. So how to calculate it? We have to calculate. Let's say this is A, B, B. So we had the mean is A plus B divided by 4. So the B is in the circle left, so it's great. So we have to minus 180 in order to get back to 96. So it's very easy. I sure that everyone can calculate it. Plus Okay, so this is the mean of the Burrata ke Matahari. So we write it down. Okay. Same also for the set 2 observation data. After we calculate, we will get a value of 96.09 and 49. After we calculate with A, B divided by 4. Okay. So next, for this part, the total station reading is in the zenith angle, while for our desired value is in the altitude value. So this is a zenith angle. This is a zenith angle. So how to get a altitude value? So we have to 90 degree minus the zenith angle or the total station value, so that we can get an altitude angle. So that we have to calculate as 90 degree minus the value, and for the circle right we have to use a value minus 270. Okay, let's say this is A, B, B. The mean will be A plus A plus B over by 4. Okay, so after calculate, I calculate for you for one example. Then plus 90 minus 74, 52, 50 plus 2F5, D 50, negative 270 plus 2F5, 21, 20, negative. Okay, then we get the answer divided by 4. We will get value of 15, 12, 45 for the Burrata Tinjau altitude angle. So the biasan we will read from the table of Perez error. So I will put a diagram of the Perez table in the screen. Okay, from the table we can get the value of the value for the correction, which is for the altitude angle 15, 12, but the nearest value in the table is 15, 10. So we get a value, it is the value negative 3 minutes and 04 seconds. So we go back to the booking form. Okay, this is the value we get from the table. After we get the table, we will write down in this column, and we will calculate for the Tinjau di Lalas, which is this minus this A, B, this A minus B. So we will get answer 15, 09 and 41. Okay, same for the set B calculation. For the set B calculation is totally the same as calculation for set 1, is 90 minus answer minus reading and 270. We add it on and get a mean value. So after we calculate, we will get a value of 16, 18, 28, and we read for the biasan. For the table, the correction will be 0, negative 2 and 50. This is the value I get from the table of biasan. And the last one is the Tinjau di Lalas we will get from the A minus B. So it will be 16, 15 and 38 after we calculate it. Okay, now we have finished the calculation for part A. Now we will continue for the calculation in part B. So this is the calculation for part B. the coordinate of the station given in eastern northing is 22017 and negative 4900.0 meter. So this is the data given. We can find it in the plan acui of any station from the table of the plan acui. So for the coordinate origin, since we are doing this observation in the state of Pahang, we are doing in the Pahang. So the coordinate origin, we need to refer to the state Cassini coordinate. So I will put a diagram of the coordinate in the video. So in the diagram, we can see the Cassini solenoid for the eastern and northern for the Pahang state is 0, 0. Okay, and you can see the latitude value for the Pahang state is 03 degree, 42 minutes and 39 seconds. These two values we will use it in our booking form later on. So we go back to the booking form right now. Okay, in the booking form we will copy just now the value just now is the coordinate origin. I say is 0, 0. Okay, for the Garistan origin U is I mentioned just now the latitude for the station, the latitude for the origin for Pahang, which is in 34239 seconds as just in the diagram just now. Okay, for the Jonas Lycée, it is a summation of A and B, A plus B, so it will be the same value. Okay, same value. Okay, for the Jonas Lycée, this value we multiply by the value 0.03256. Okay, 22017 multiplied by 0.03256. Okay. Okay, after we press the calculator, we will get this value, but this value is in the unit of second. We have to divide it by 3600 in order to get it in the unit of degree millisecond. So after we divide that, we will get a degree millisecond of value 0, 11, 57. Then we got right down in this column. So the Garisan Lintang for station U is AB, A plus B. It's a summation. Why? This is because, okay, this is because this is the Garisan Lintang for origin. Okay, is equal to 34249 seconds just now. Okay, but you see, this is a Lycée of the move of the station, means this is a positive, positive, because this is Utara. This means our station is located outside the Garisan origin of this. This is our station, Garisan Lintang. Okay, so the difference here is just now we calculate is 11, 0, 11 and 57 seconds. So what is the value here? So we have to add it on. Is 34249. Add on with the differences here. So we will get a Garisan Lintang of our station U. Okay, so we add it on. 34239 plus 0, 11, 57. So okay, we get a value 35236. 35436. Okay, after we get this value, Okay, next we continue with the Timur and Barat for the candidate. The Garisan Bujo is formula is the Garisan Bujo formula is given by Jumla per se multiplied by 0.03246. So this is a value -4 multiply with 0.03246. Okay, we'll get a value of negative 159. But you take note this is in a unit of second, so we don't need to divide it by 3600. So we just copy write down the answer. Okay, for this column we have to use the cell garisan bujo multiply with sign garisan lintang. Garisan lintang is the garisan lintang for station U. So in the calculator we use the cell garisan lintang, which is -159.5 multiply with sign garisan lintang U 3 5537. Okay, we will get answer of -10 point something. Okay, 0.75 second. For the tirusan, we just inverse the sign of this column. So this is negative, we turn it into positive. Then in the nearest answer is 11 second. Okay, so this is the overall calculation for the part B. So next is the calculation for part C. This is the date of our observation sample. So this is the solar observation is done on 7 March 2003. So we have to look for the almanac, for the 7 March 2003. So how to search the almanac, I will demo in the computer later on. Okay, for the almanac, you can search in the Google by type nautical almanac and press enter. Then go to this website, the nauticalαλmanac.com, and we search for the year of almanac we need. For this, we can search for the nautical almanac, or you can search for the sun almanac only. The nautical almanac is included the star in there. So we need the year of 2003, and we press go. Find the date of our observation. So this is on the 7th March. So we need to find where is the 7th March. Here is March of 20. Okay. This is the 7th March, 527, 567. So 527, 5667. So this is the almanac for the date 7. So this is the time. This is the declination. The value we need is the declination, and d, this small letter d, is the changes for every hour in the degree of, in the unit of minutes. So from the table, we just get down for the zero almanac, which is -531.4 minutes. So we go back to the booking form. For the Bukit form, we have to write down the waktu umum pendidikan, which is getting from here, this value. We copy. And for the waktu umum pendidikan untuk set 2 pun sama. So the setelah is the difference between these two times is 0.4. Okay, for the almanac just now, I have copy down the almanac for you. Okay, this is a UT, is mean for the universal time. This is the declination of the sun on the date I want is 07 March 2003. Declination value is -5 degree, 31, 24. And this is small letter d is the changes of every hour is 1 minute. So I convert it into second for more easier for our calculation later on. It's 60 seconds. So as you can see, this column is sudut istiwa pada watt jam UT. So at this sample, the nearest hour is 0, so we take out 0 UT time. So for these three, we copy from the almanac for the 0 hour. 0 UT is this value, -5, 31, 24. Then the changes for every hour we write down here. For since it is a positive, I write a positive sign here. Okay, for the selisih is we calculate by using the time and the changes of every hour. So for the time is 0:30 means 0 degree, 30 minutes, 0 hour 30 minutes, multiply with the changes in second. So we type it as 0, 0, 16 second, 0, 0, 16 second. We press enter, we will get a reading of 13 seconds. Since the changes is positive, the selisih also will be positive. Okay. Then the sudut istiwa pada waktu pendidikan is the summation of A, B. This is A plus B. So sudut waktu pada waktu pendidikan, we can say understand it as this is the interpolation of the almanac. We have to find the declination of the sun when we are having a time of 0 hour 30 minutes. So after we calculate it, A plus B, we will get a value of -5 plus 0, 0, 30. Okay, we will get a value of -5, 30, 55. Means at the time of observation of 30 minutes UT time, so we will have a declination of the sun's -30, 30 and 54. Okay, this is the waktu pendidikan, sudut istiwa waktu pendidikan pada our observation time 30 minutes, 0 hour for here. Okay, A plus B, A plus B. Okay, so for the jarak kutub is like this. Jarak kutub is the distance from the north celestial pole to the sun. So since the almanac said that the sun declination is -5, means the sun is located in the south hemisphere. So the polar distance will be 90 degree plus with the declination just now in the almanac. This can be found in the almanac. So the polar distance will be, since you can see in the diagram, it will be greater than 90 degree. If now the sun is located, if the almanac given is positive, means the sun is located in the north hemisphere. The sun is here, so the polar distance will be always less than 90 degree. This is the tip for us to easier memorize the concept. So here we have to find the polar distance. Since the almanac said that the sun is declination is negative, means the sun is located in the south hemisphere. So what is the polar distance of the sun? What is the polar distance for this sample data? So the polar distance will be 95, 90, 55. So I said this 90 degree plus the declination. The declination we take as modulus. So it will be always greater than 90 degree. Since the distance is more longer, you have to reach at the south hemisphere, while for the north is always less than 90 degree. So okay, for the Gaisan Lintang, we copy it from the Gaisan Lintang station U. We just copy it. And the tinjau di lalas. Okay, for the tinjau di lalas, we copy it from here. And the purata ke matahari, we copy from here. And the purata ke tia, we copy from here. Okay, purata ke matahari, copy. Purata ke tia, copy. Okay, and the tirusan, we copy from here, positive 11. Positive. Okay, right now we can continue our calculation in part C. So, how to calculate the azimuth Matahari yang dikira? So, by using the formula, cosine azimuth equal to cos polar distance minus sine latitude sine altitude over by cos latitude cos altitude. This is alpha, actually is altitude, as I mentioned just now, altitude. And Gaisan Lintang is our latitude or station, and Jarak Kutub is our polar distance. So by using the formula just now, okay, calculator here. I demo how to calculate. The formula is given by cos polar distance minus sine latitude sine altitude divided by cos latitude cos altitude. So we substitute into the equation is for polar distance 95, 90, 15. For V is this Gaisan Lintang 3, 5, 4, 3, 6. And last one for the tinjau di lalas altitude 15, 09, 41. Okay. Then since just now it said is cosine azimuth, so we have to inverse cos to get the answer. Then after we get the answer, this is the answer for azimuth matahari yang dikira. Okay, sorry, there is a mistake just now. Just now is 95, 30, 54. So I have typo just now. This is 54, 95, 30, 54 for the Jalan Kutub. For the Gaisan Lintang, 95436. For the altitude, 150941. Okay, after we get answer, we have to inverse cos in order to get a value. 96.47, 44 seconds. Okay, this is the Azimuth Matahari at that moment. So let's say now we have calculated the. This is the example for the morning sun. Let's say now we have an observation in the evening. The evening sun azimuth. We have to, after we get a calculation, we have to use 360 minus the answer in order to get the afternoon sun azimuth. Since the afternoon sun, we have to count. We have to calculate it in a counterclockwise direction, while the morning sun we count it in the clockwise direction. So this is a example. You just now get a 96 for the azimuth. If for the afternoon sun, we will get 296. This is the azimuth for the afternoon sun. Let's say for the example. So in this example, we have in the morning sun, because we have doing an observation at the 8 o'clock in the morning. So next, the selisih is azimuth minus the. Okay, next is the selisih equal to azimuth minus didikan. This means this A, this is B. The general equation is A minus B. So we have calculate. To calculate 96 so 4 minus 2. Okay, we will get the answer of 0.4438. Then tanda rujukan sebenar is the equation of selisih tambah tanda rujukannya di titik. Means this is A plus B. This A, this is B. Okay, we just add on with 162. We'll get the answer for 162.4438. For the pembentukan aras is 0 in this equation, this sample, because our instrument bubble labeling is in a good condition. Okay, for the bubble gelombang, this is all in 2, value of 2, because the bubble is in the stable condition. So this summation of right hand side and left hand side is add. Then by use is add. Then by using a formula here, pembentukan aras, summation of left hand side minus right hand side minus left hand side is equal to 0. For this example is at minus s. So 0. Whatever multiply with 0, it will be 0. So this is the reason why we get a 0 here. And the dilution is 11 with here. So the bearing grid to tanda rujukan is the summation of all, means A plus B plus C is A, B, C. A, B, C. We add it on some all 4438 plus 0 plus 11 seconds, and we will get answer 162.4449. Okay, this is the calculation for set 1, bearing grid to tanda rujukan for observation 1. Well, for the observation 2, we repeat the calculation again. So I will make it faster here. Then the selisih for the observation 2 is at the time 34, 0 hour 34 minutes. So this 0 hour 34 minutes multiplied with the changes is 60. 0.060. So we have a selisih of 34 seconds. Then after the interpolation calculation, we get a what2 panitic, which is A plus B, -5, 31, 24, plus 0, 0, 34. Okay, we will get a what2 panitic is -5, 30, 15. And the polar resistance, the sun is in the south, so it's always greater than 90, so it's 95. Okay, the tinja details we copy all from the calculation in part A. Then we copy Okay, now we calculate the azimuth sun, azimuth of the sun. Okay, this is the value of our azimuth sun for the observation set 2. Okay, this is the observation sun of our observation set 2. Then we continue for the Cerapan is A minus B. Zero, 4, 4, 37. And the tanda rujukan sempurna is A plus B. 162, 4437. Aras is 0, jurusan positive 11, and the final is A plus ABC. 162, 44, 48. So the purat, okay, so this the value we get. The Purata bearing grid to TR is the average of this set, observation set 1 and observation set 2. The Purata it will be 162, 44, 49. In the backleading, the observation of set 1 and set 2, it should be always less than 10 seconds. So that it will be acceptable for our calculation right now. Okay, that's all for the calculation for part C. So this calculation is very simple because if you divide it into 3 zones, part A, part B, and part C, all the calculation will be very easy for you in order to calculate. Okay, that's all. Thank you everyone.